identical or not? So if I draw this structure, it is CH3, CH, CH2, 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 CH2. This is a structure, okay? I will check, is this this is one carbon environment because its neighbor. And when we talk about carbon environment, we talk in terms of their neighbor, okay? Even three hydrogens are attached to this, but it has another carbon, CH3 is there. So this is one carbon environment. This is a second carbon environment. This is a third carbon environment. This is a fourth carbon environment. And this is a fifth carbon environment. So five different carbon environments are there. So the correct answer for this one should be C. Is it clear? How five different carbon environments, five different neighbors? Is it clear? Okay. The next we have is question 16. In high resolution NMR of propane to all, there are, so propane to all is there. We have CH3. Then we have C, which is all is there. Okay. Propane to all. This is one hydrogen environment. This is one hydrogen environment. This is second hydrogen environment. This is a third hydrogen environment, and this one is a fourth hydrogen environment. So four hydrogen environments are there. So the question is, it's a high resolution. For high resolution, we always check the neighbor. Okay. We check the neighbors, how many are in the neighbor. So let's say the environment A contain three hydrogen, but how many are neighbor? Neighbor is having one because this hydrogen, this in its neighbor it has one hydrogen. So A will give us a singlet. No, sorry, doublet. I mean, because A will be a doublet because neighbor is one. If I call this as B, B is also having three hydrogen, and B actually A and B are identical in terms of OH is attached, CH3 is there, yeah. So this I can count as identical. I can also say this as A. Why? Because when I realized that it's actually the same because it's just a CH3 here, CH3 here, so both of them are A. So total A is having six hydrogen in the environment and it will be a doublet. What about this one? This hydrogen, how many neighboring hydrogen are there? Three here and three here, six. So in this hydrogen, one hydrogen in the environment, six are there. So it six plus one, seven. So it will be heptet, or seven. And this hydrogen, oxygen does not have any, like the neighbor, whenever it's there, we check oxygen does not have any hydrogen. Always it will be a singlet because of a OH. So there will be one singlet, one doublet, and one heptet. Singlet, doublet, and a heptet. So A will be the right answer. Is it clear? So for OH is always a singlet. Like whenever OH of a carboxylic acid, it's always a singlet. What is the minimum volume of oxygen gas combined at room temperature and pressure for a combustion of a 9.2 gram of this compound C3 H8O3 plus O2 will give CO2 plus H2O. Always write a balance equation. 3 carbon are needed here, 8 hydrogen, so this should be 4, and oxygen 6, and plus 4, 10. 3 are already there. So how many I need? 7 by 2, because I need 10 total. Now, first we'll find the moles of this compound. Moles equal mass in gram divided by molar mass. So it will be 0.1. So the ratio is 0.1 mole we got. Ratio is 1 is to 3.5. So 0.1 will be X. Cross multiply, so 0.35 mole we'll get. From 0.35 mole multiply by 24. So 0.35 multiplied by 24. What's the answer? 0.35 times 24. 8.4. Okay, B will be the right answer. Is it clear, this one? The amount of oxygen which we need. So first we got the moles of oxygen, moles of that compound.